All right, we're in section 2 or set 2, Swyk number 1 of week 4. Now, you got this equation y equals 4 to the x, or 3 to the x, excuse me. The number that's in front of it is a 1, folks. That's right. Now, we never write it. You know, you'd get thrown out of a party if you wrote 1 times 3 to the x, because everybody knows the 1's there. You know, people hate those kind of things at parties. Anyway, so that is the y-intercept. You are correct. And the growth factor is greater than 1, so definitely growth, not decay. There's only one graph here that it looks like exponential growth. So that wasn't too hard, you know. Now, if you take a look at it closer, you do have to have correct points. If you wanted to make a table, you could. There's nothing wrong with that. If you plug in a 0, you get 1. If you plug in a 1, you get 3. And, of course, those points do show up on the graph. Get to example 2 here. Now, this one, they kind of do something, they kind of disguise something here. We've got 3 squared, right? And 3 squared is 9. So this is really y equals 9 to the x. You know, with the a value being 1, like we already know. 9 is definitely bigger than 1, so we're talking exponential growth. And oh, look. Only one graph is exponential growth. Man, I got to make these multiple choice questions harder. So on the next one, we're looking for exponential decay because 1/6 is smaller than 1. It does have an a value of 1. If they ever try to do this trick on you, remember 6 to the negative x. That's really 6 to the negative first to the x. And so 6 to the negative first is 1/6. I see that a lot in SAT, ACT type stuff where they're trying to trick you and say, hey, there's a 6. It must be exponential growth. But the negative exponent makes it decay. So there's only one graph that looks like exponential. Well, you got 2 that actually look like exponential. 1 growth, 1 decay. So you have to know that you're dealing with decay. So at least they tried to trick you a little bit. Question 4. If you have the graph y equals 1/3 to the x, we're talking exponential decay. It looks something like this. The line that it's getting closer and closer and closer to is the x-axis, y equals 0. There is no shift up or down, so since they're not moving it up and down, it's just staying right there. It's not changing. That's why we have this answer. Question 5. They are starting to move it. Now you can see that the red function is a growth function. You'll notice that the blue one there, g of x, is also a growth function. So you'll notice I crossed off a and d because a and d, one's a growth and one's a decay. They're not going to switch on you. All they're doing is taking the whole graph and moving it up 2 units. So you need to start with the red one, go to the blue one, and it has to go up 2. So obviously that's choice B. Now how do I know it's up 2? Well, it's on the outside of the function. So we're going to be looking at things that affect the left and right movement. That would be something up with the exponent. Kind of similar to something like this. Like remember when we had like x cubed and we put a +2 on the outside, this would take the whole graph and move it up 2 because it's on the outside, you know, versus something like this where it's on the inside, and you know that would be like right 1. We'll see that happen here with the exponent here in a little bit. But yes, so we would indicate here 2 units up on the second part of question 5, 2 units up. When you get to question 6, once again, just 3 units up. So we're looking for a graph, an exponential growth function. A and D did not work. They actually have a negative a value because the negative a value causes it to flip over the x-axis. But we clearly do not have that. So it's B is the only one that has exponential growth, and it is shifted up 3 units. When you do shift things up or down, you change the asymptote. So if they ever ask me that question, which they will eventually. That was the end of Swyk 1. Okay, we're done with that Swyk. Get that one done, and then come back to me.